in-use energy monitoring and why it's important. We're going to tackle the question in further detail, trying to share ideas on how and why you might tackle your organization or business. So let's dig into the question and we'll unpack it a little. Why is it so important and likely to get even more so into the future? Well, energy costs dramatically increased. Okay, they've gone down a little, but they're likely to go back up. And it's starting to be a real pressure for people. We need to understand the energy use and the patterns across a building or estate so that we can see what's occurring and why. We need to identify places to save energy and money, and of course the planet. The spot prices on energy are likely in this country. In the Nordics, a spot price is published for every hour, 24 hours in advance. So, going into the future, it may be that we have hourly tariffs, and we'll really need to understand where we are with our energy. There's a corporate responsibility to lower carbon footprint and tackle climate change. There's an enhanced brand reputation for doing the right thing, for being sustainable. There's ESOS compliance. It's an energy assessment. It's established by the Energy Savings Opportunity Scheme. It's a mandatory scheme, and the criteria can be found at gov.uk. And it's thought that the criteria is likely to work downwards until even very small businesses are under the umbrella. And of course, I don't know if you know, you can get access to better funding or lending. Rolls-Royce, for example, access more preferential lending depending on their efforts and ratings in sustainability and responsibility. So it could make a big difference to your business. And finally, the amalgamation of everything that we just looked at. If you can't measure it, you can't improve it. And getting an immediate picture of your energy can be important in enacting a change, using lower rates, greener energy, or just trying to eliminate the waste. So how are we going to do it? And this is where it becomes, for me, a bit more interesting. I'm a visual person, so I think of energy monitoring like a river's journey, from the source right through to the end. And if we invert it, just to make it easier to see upstream to downstream in a top to bottom image, we can think about where in our organization or building, where it's best to consider the first measurement. We can measure here, for instance. This is much like measuring an incoming supply, a building, for instance. It's a great start point. This will measure all of the total energy usage and deliver it back immediately to a dashboard as requested. Or here, if we just want to measure a part of the electrical system and everything that's downstream of it. So say a part of a manufacturing process, a separate warehouse, or a part of a hospital, for instance. Here, it could be a substation, and it could be providing power for 2 warehouses in this instance as it branches out. Or we could measure it separately at these 2 points, add them together to get the substation power usage. What it does here, though, is it allows us to see some separation. A key point is that depending on the needs, it might be important to know energy use all the way through your organization, right down to the most granular part possible. And we're going to look at this as we go through, hopefully in a logical order. And if we want to find it and eliminate any waste, it could be essential. So how we do energy monitoring in 2024. So let's take a look how you might undertake it. For many years, There was a wired approach, and that was all that was possible, and it is still possible. And there are many, many devices and ways with which we can do wired energy monitoring. And obviously, just like the way things have shifted in our home life, wireless has changed the game in terms of how we could undertake deployment of energy monitoring in 2024. It's quicker, often more cost effective, and of course, many wireless infrastructures can be used and reused for other solutions, often years into the future. So once your wireless infrastructure is in, it could mean only extra devices are needed. And as you extend it, of course, the costs will literally collapse. So wired or wireless, what about devices? I mean, if you don't know too much about energy monitoring, who makes devices? What's the choice? How might we go about it? Well, the answer is in terms of manufacturers, all the usual suspects. They all make devices from the world leaders right to the small innovators. They come in all shapes and sizes. And for perspective, on AssetBook, we now have over 1.5 million smart devices that are AssetBook ready. So you can imagine the list, and it grows daily. And energy monitoring is a category with many options, shapes, sizes, and capabilities. And we're going to go a little bit deeper into that. But how about protocols? There's lots of choice for wired or wireless and many open standards. We always advocate this approach if possible, as well as many other proprietary ones too. Well, here's a few, and I'm sure there'll be many that you know. I've added in a few others. I've added in DALI 2, which is essentially a lighting protocol, and Kasambi, another wireless lighting provider. But there are possible ways with which to get energy data and meaningful energy data too. And then other things, there's lots of choice, some like Wi-Fi that might be ubiquitous to buildings, Zigbee or Bluetooth that offer a mesh technology so that information can be passed. Then there's LoRa, which is a wide area network. And of course, we add cellular, which could be a useful way to deploy in certain cases. Then, of course, there's the old-fashioned, maybe more industrialized BACnet and Modbus, but they're established methods with which we might choose to go for our energy monitoring. So how are we going to get the data? Well, smart meters, device-wise, are an obvious one. But in our connected world, we can get information from all manner of other devices too. If we have solar, we might get inverter information that helps us understand how much and where the energy was actually delivered from. EV chargers are another source of information. They use the OCPP, which is the Open Charge Point Protocol. Not easy for you to say. Even the dumbest chargers could deliver data on charges, energy use, etc. And also, if we use an enabler such as AssetBook or similar, we can interrogate them even further, and we can even do things like load balancing, payments, and ensure only the power that's available is taken at source. So there are other advantages there. We can use connected lighting. That could be any type of connected lighting. It could be street lighting, indoor or outdoor lighting. We can get insights on occupancy. As an addition, we can set dimming levels, turn them on and off, which also enables energy saving. So when we think about energy monitoring, we often don't talk about lighting, but it could be a big part. And I think it's really, if you already have smart lighting, then it can be a great energy reporting asset. And really, you're absolutely at device level reporting, which is a very, very granular approach. Or you could add smart bulbs. And in this case, it could be a really simple way just to add another easy granular accessory. And it's another connected asset. Just be wary to ensure you get a professional product that performs when you buy such things like a smart bulb. And finally, we could add something like a smart socket. It's another great low cost connected device. It offers lots of granular energy information. And with even with this simple type of device, there are some really clever possible add-ons for further value. And then, of course, in the non-physical category, we have two further tools that are perfect for energy monitoring and management. We can add metadata to any asset or device that allows data. And in a more rudimentary way, we could pair a 10-watt light with a connected dimmer. And then by using this metadata, we can measure the power used by taking the power versus the dimming curve, the on time, and thus giving you energy use, for instance. And we can also use a virtual asset, such as I said, maybe the published spot price of electricity as part of the cost calculation. Or if it was in a changing room and the connected shower fails, we could set a rule or automation that also turns off the light above it. So it avoids users trying to use it, and it also avoids wasted energy. So often a physical or a virtual data can be used for incremental gains or to help in that elimination of waste. And in terms of infrastructure, I guess you need a gateway or router or cellular compatible device if choosing to use NB IoT or LTEM, etc. And some kind of visualization solution to normalize and display the data. And maybe a way to automate it too, if you want to action the insights or the opportunities. There's lots of things we need, but in a step-by-step approach, we're trying to give you the information. And then how will we do this? With an end-to-end solution, maybe such as Asset Book that does everything and more. So, I apologize for the product placement there. Other solutions are available. So let's take a look maybe at a couple of real examples of where we might do the energy monitoring and how it might be used there. So in MDU or multiple dwelling units, we see them often, flats, apartments, retirement homes. And MDU is an interesting one, I think, because it's a great visual way to have a look at energy reporting. So there could be, in this instance, 4 flats. It could be 100 plus. They've got associated electrical systems. And then if we think back to our river and delta system in your mind, so you have an intake from the LEB and a fuse and a meter somewhere, probably that's not shown. A distribution board at source, feeding 4 smaller boards, 1 per property, and a 5th board for communal areas, say fire alarm, emergency lighting, cleaners, sockets, etc. This instance could just as easily be an office, a factory, a school, public place, in principle, though. So where, obviously, as a technology company, we would probably choose to use a wireless topology and our Asset Book platform, but we'll come to that later. But for the purpose of the webinar, as an easy explainer of the wider options, if we want to get a measurement and baseline our energy use, we can just use option 1 here. Remember, if you install a smart meter, we can pull that information from it wirelessly or wired. Obviously, there is the option here to just have a standard, what we'd call a dumb meter, but what it means is you'd have to go and read it anytime you need to understand the energy use, which is kind of a little bit self-defeating. There are now devices which might act as a camera to go over the top of the energy meter, a dumb meter, and it'll upload it on a regular basis. But we would still say a smart meter allows much further interrogation and information passing. And then we have option 2, add in a device within a distribution board and it feeds information back. So in this instance, a main switch device providing a singular energy use of everything that's downstream of it. There's plenty of these kind of products available on the market. A fantastic way to add energy monitoring. If we want to get a more granular and a more sub-distribution baseline, so maybe per flat in option 1 here, we can put a smart device, CT clamps, across 4 circuits, or in this case, 4 flats, and then provide that information back to a software or visualization, a simpler way in some cases, maybe to get more granular information. And then for option 2, we can use a device to go within the distribution board again, but at this time, instead of at the incoming circuit level, we're putting it at the outgoing circuit level. And this will again give us a sub-distribution level, and it will show us how to obtain energy readings. And then as an aside, you could add a switch if you wanted to cover just the fire system if you wanted to. I mean, in this instance, it's showing the communal board only. And then using option 1 or 2 in that last slide, you would actually end up with the ability to measure the energy from downstream. So really, you're going to get an amalgamated reading for each of the flats at circuit level or for the communal area, which could be billed to a separate management company, for instance. And within that, you're going to get all of the circuits. And there could be other things as well where we look at it in that way. And in flats or apartments, I guess the user is generally paying their own costs. They're policing it themselves. They're probably in real terms quite low energy users. So if they were to get a big bill, for instance, it would focus their mind too. So in this instance, I guess if organizations such as retirement home builders wanted to roll up these costs into yearly service charges, they may want to go further and investigate where the energy is used. But generally, for an MDU or a multiple dwelling unit, that would probably be as far as you'd need to go in terms of how you're looking at the energy use. But what about a university campus, for instance? A university campus is similar infrastructure, but has lots of students on site. The electricity costs can be excessive due to energy abuse. Some students maybe arrive each year, they plug in almost everything they own, they leave the lights on almost permanently, and even though they might be in class all day, Monday to Friday, and out on some evenings, there's a need to eliminate some waste, definitely drive down some costs, and also change some behaviors. So how would we go about this one? Well, if you only want or need to use tech, past distribution board level and on to device level, I guess we could use something like a wireless lighting, such as Kasambi. It can report on energy use at device level, the luminaire, the light fixture, but it also adds other wonderful insights such as operational times, daylight harvesting options, dimming levels, occupational information. So now you're measuring at the very final destination of the power. And because of this, there are many advantages. We could also pimp our small power in the same way. So we could record that energy use, as I mentioned earlier. We can profile the products that are plugged into it. We can analyze and report them. We could lock out inappropriate products, say students turning up with their own heaters, for instance, and the campus is climate controlled. So we could lock out any inappropriate products. We could turn off any unstable devices. So any devices that start to really fluctuate, we could actually program them to turn off through that socket. And we can also do things like change behaviors, where maybe on the socket we could show when the energy available is green energy and when it's not. So it's about behavioral change, some of these things. A great way to get down to really granular energy monitoring. And for the university campus, we can really provide real solutions. With the data, we can act, we can push the information to the users and share it. We can publish charts. So not finger pointing or shaming, but more a pat on the back to those that are being sustainable. We can definitely show and educate the users for behavioral change. We can meet targets, drive down costs, and we can be more sustainable. So there's many, many reasons why it's important to have energy monitoring. And the same applies with any other opportunity, a factory, an estate. We just need, all we need is to decide what we want to monitor, why, and where. And in a production factory, for instance, we could actually go further and calculate the cost per widget or even the embodied carbon from a process. If you know what it is useful or valuable to measure, we can measure it. You can get insights, education, ongoing savings, and less waste. Now, having looked at the devices, the infrastructure, and a few options, I guess we need to look at where we think the magic happens, how we make things easier, but infinitely more powerful. So the asset management, that's the next level to just attaching devices and creating infrastructures and pulling or pushing data. We're going to have a quick look at that and why you might want to do that. So let's take a quick look at an asset. You can have an asset, a data value from any asset. All the asset classes are usually presented uniformly, which is a great way, the normalizing of the data. Additional data can be added to the asset, specifications, BIM information, drawings, etc., location, zones, and tags, link things together. They're all ways to have individual assets working as part of subsets and groups. We can put locations in, we can have individual warnings, alarm thresholds, and we can set them for any reported parameters. We can have individual control of assets, those that can do real world functions, so dimmers, dimming, switches, turning things on or off. Whatever they're meant to do, we can have control of that. Some great visualizations there of what you might see. And then all of the data in one single pane of glass view. This is where it gets much easier. So dashboards, we allow dashboard deployment partners or users to create them, edit them. We can download the data interactively. They can be downloaded periodically. Any live parameter here can be pulled. You can share your data and insights with the right stakeholders, create custom dashboards for any business process or user. So whoever is in your organization, they can have access to any information that might assist them in their own job. These are, of course, the next level of just taking a base energy monitoring unit. And of course, automations, triggers, and actions. You know, what happens next if we take a measurement? With AssetBook, it's a no-code platform, so simple and quick access to automations, parameters, virtual parameters, triggers, and alarms. You know, one of the things about finding waste is maybe there's an automation that might help eliminate it. If there's no occupancy in a room, we can trigger turning off that light. If there's a need to do something, you know, turn off lights on a bank holiday, it can be done. Even if it's forgotten, it can be done. And of course, there's cost savings, efficiencies, better security, and of course, compliance. Analytics. This is really taking that data that's been normalized and really using it. So the more data you have, the more informed decisions that can be made using powerful analytics. You can put any kind of information over any other kind of information. And now we have this unification of data. So we can have lights, small power, we could have occupancy, we could have, you know, the HVAC system. We could be using all of these things to put the data on top of each other. And then that data we could put on top of each other for multi-buildings, estates, you know, worldwide assets. And the digitalization of this, you know, one of the upsides to Energy reporting is it starts a digitalization of your business, the power to manage anything from a single device to a multi-site estate. You can manage everything uniformly, you can use data comparisons, you can have maps, you can have live data. It's all there, really. You can reconfigure, redeploy, and reshape your digital world as necessary without costly bills or outsourced expertise. If you want to see your assets all around the globe and in a traffic light system so that you know the green sites, for instance, are working as they should, the orange sites have some sort of warning or oncoming compliance issue maybe, and the red sites, they definitely have a warning or a fault. It's so easy to see what you're doing with your digital world. So the conclusion in 2024, it is actually much easier and more cost effective than you think to get accurate in-use energy monitoring data and from all kinds of devices. So we must think outside of just we can only get energy information from meters. It costs much less than you think with a single phase wireless devices starting from under £100, three-phase devices under £350, and something like a smart plug, it could, for the product itself, it could be maybe only around £30. It's all affordable. And, just as a note, if you need devices accurate enough to bill from, so if you sublet or you charge internal cost centers, etc., you might want to think about getting something like a mid-certified device, which is, a calibrated device suitable for ongoing charges. And now as we've shown you, you can measure anywhere and everywhere. You can hive it all up. You can do it simply, or you can hive it to dashboards and analyze it, report on it accurately, and really bring about the real change in your organization. And as we're doing this type of thing day in, day out, we thought maybe give you a few tips that also might help. An obvious one, but consider security, especially if you're combining solutions or using a multi-vendor approach. The further you spread your digital wings, the more this needs to be at the front and the center. Consider which protocol or protocols to use. A single protocol always seems appealing and to make sense, but a one size fits all is unlikely. And also, you're trying to build a digitalization for maybe the next 5 to 10 years. So a multi-protocol approach is obviously most likely from our perspective. And the more you stick with open standards and non-proprietary communications, the easier the future will be for you as an organization. That's an obvious one. Do be strategic and maybe wireframe out a whole digitalization strategy, or at least how you might see it today, as a map or a start point. Energy monitoring could even be the start point, but just maybe have an idea of how it might look and how it might evolve from here. But do be courageous and understand that you're taking a digitalization journey, and putting it off until you feel you have all the answers is just likely to cost more time and more money. So be committed to change, to using technology to help and shape your organization. And a quote from me this time: if we can make technology adoption easier, everybody benefits. And we really believe in that. And, that's what today is about. We want to show you how you go and get it done, wherever you want to go and get it done, because we all need to do our bit for the planet, and our businesses will benefit in multitudes.